Hi, this is Nathan Tintle. In this Learning Goal video, we will discuss how to apply the 3S strategy when using the correlation coefficient. We will use the exercise and mood example from the Introduction to Statistical Investigations textbook. When testing correlation, the null hypothesis is much like we've seen before in this course, that there's no association between the two variables, specifically between exercise and mood in the population. Another way of stating this is that the correlation coefficient in the population is equal to 0. Alternatively, we can say that there is an association between exercise and mood in the population. To apply the 3S strategy, we take a very similar approach to what we've done before. First, we compute the statistic. In this case, that's the correlation coefficient, negative 0.187. Then we simulate. Well, we know that we simulate the null hypothesis, but how will we do it in this case? Ultimately, we'll use an applet. But the way you can think of this is very similar to what we've seen before when we had multiple groups being compared. Specifically, when we had, say, 3 groups that we were comparing, we shuffled slips of paper representing the response variable and redistributed those values to the groups. The only difference here is that our explanatory variable has more than just 3 groups. In fact, you often have as many values for the explanatory variable as you have observational units. We can follow the similar strategy, though, in that we can take each response variable value, mix it up, and redistribute it to each person because each person acts like their own group. Let's see how this works in the applet. Here in the applet, we've pasted the mood and exercise data in, and we have the scatter plot. When we click Show Shuffle Options, we have the ability to shuffle the Y values. When I click on that button, what you'll see is that the exercise scores, 72.2, 76.1, 68.3, and so on, are the same in both the original data on the left and the shuffled data on the right. What's changed are the mood scores. We've shuffled them up. That is, we've redistributed the mood scores to each individual, as we discussed before. We know that when we simulate, we need to do this many times, each time computing the same value. In this case, the value we want to compute each time is the correlation. The shuffled correlation coefficient in this data set is 0. If I shuffle again, I get a different shuffled correlation, this time 0.16. We can keep shuffling, each time getting another shuffled correlation, and each time adding a value onto the simulated null distribution. Ultimately, I'd like to get many shuffled correlations and yield a distribution of shuffled correlations. Notice that this null distribution is centered around 0, as we have seen before. We can also see that shuffled correlations tend to fall between around 0.4, negative 0.4, up to around positive 0.4, showing us that our shuffled correlation is something that happens quite frequently. To find the p-value, simply enter the observed correlation, 0.187, click Beyond for two-sided, then click Count to get a p-value of approximately 0.31. No statistical significance here. A couple of final comments. This is the same 3S strategy we've seen throughout the course. Compute the statistic, the correlation coefficient. Simulate the null hypothesis. Compute strength of evidence by comparing the simulated statistics to the observed statistic. The simulation redistributes Y values to X values to simulate no association, which is equivalent to a correlation coefficient of 0.